In 2006, NASA initiated the New Horizons mission to investigate Pluto, then considered the ninth planet in the solar system. After a 9-year journey, New Horizons successfully reached Pluto, marking the first spacecraft to explore this distant world. Presently, the probe has surpassed 50 astronomical units from Earth, equivalent to over 7.5 billion kilometers. Despite ongoing analysis of data from the Pluto flyby, recent studies propose that Pluto is not as inert as initially perceived. Astronomers have identified peculiarities in the images transmitted by the New Horizons probe, challenging the assumption of Pluto's tranquility. This raises questions about the potential existence of life on Pluto. Pluto, characterized by an icy composition with a core of frozen nitrogen and carbon monoxide ices, holds the distinction of being the first discovery in the Kuiper Belt and remains the largest known body in that region. Nevertheless, debates about Pluto's planetary status arose in the 1990s with the discovery of comparable-sized objects in the Kuiper Belt. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, but this did not diminish its allure for exploration. Examining the images captured by New Horizons, astronomers observed a remarkable and unforeseen feature not found on any other planet in the solar system. The surface of Pluto displayed numerous uneven volcanoes with varying elevations, and remarkably, there were no nearby impact craters from asteroids or meteors. Moreover, there was a lack of evidence for plate tectonics activity, a process integral to mountain formation on Earth. Collectively, these factors suggest that the current surface of Pluto resulted from a recent geological disturbance, potentially a volcanic eruption, occurring within the past 2 billion years. While this timeframe may appear extensive in the context of cosmic time scales, it qualifies as a relatively recent event. Examining Pluto's volcanic characteristics, 2 prominent peaks on the dwarf planet's surface have intrigued planetary scientists for an extended period. The first, known as Right Mons, spans approximately 150 kilometers in width, protruding nearly 5 kilometers above the surface, with a central depression of nearly 50 kilometers across. The second feature, named Picar Mons, reaches an impressive height of nearly 7 kilometers and boasts a width of around 225 kilometers. It's noteworthy that, despite Pluto's diameter being merely 1/6 of Earth's, the total volume of this volcano is comparable to Hawaii's Mauna Loa, one of our planet's largest volcanoes. These substantial surface features are situated at the southwest edge of the Sputnik Planitia ice sheet, the lighter region on the left side of Pluto's famous heart-shaped feature, and were initially identified during the New Horizons spacecraft's flyby of the planet in July 2015. This expanse is characterized by an ancient impact basin spanning nearly 1,000 kilometers in width, marked by folds and elevations resembling wrinkles across a sleek layer of ice. Additionally, numerous volcanic domes dot this area, with a tendency for many to coalesce into larger domes. Upon thorough examination of the imagery captured by New Horizons, researchers posit that the creation of such a terrain likely resulted from multiple eruption sites situated in proximity to one another. It is conceivable that material expelled during cryovolcanic eruptions subsequently blanketed the entire region with layers of ice. Further scrutiny reveals that the surface composition in this area predominantly comprises water ice, distinguishing it from the nitrogen or methane ice typically found in other more youthful sections of the planetary surface. This further reinforces the likelihood of cryovolcanic activity. However, for volcanoes to remain active, a consistent heat source is imperative to propel the eruptions. On Earth, volcanic energy predominantly arises from the ongoing radioactive decay within the Earth's interior. Alternatively, gravitational interactions with massive celestial bodies can also induce the necessary heat, as observed in the case of Io's volcanism. In Pluto's context, neither of these scenarios aligns well. The planet's neighboring bodies lack the strength to generate significant tidal and gravitational forces capable of warming its interior. Moreover, the quantity of rocky material within Pluto's core is insufficient to produce heat through radioactive decay. All in all, Pluto maintains an average surface temperature of approximately -240 degrees Celsius, exhibiting rock-like conditions. What is the origin of this heat? A rigid icy surface, seemingly impervious to quick melting, especially considering its considerable distance from the sun and the absence of notable external heat sources. So, the question arises, from where does this heat emanate? Taking all factors into account, the only conceivable scenario points toward the dwarf planet harboring residual heat from its formation, likely ensconced in a deep-water ocean beneath its icy crust. Similar icy bodies in our solar system, such as Saturn's moon Enceladus and Jupiter's moon Europa, are acknowledged to possess such subsurface oceans. Moreover, Enceladus has exhibited signs of regular cryovolcanism, ejecting icy material into space and contributing to the replenishment of one of Saturn's rings. It is noteworthy that extensive arrays of icy volcanoes, extending across a field and coalescing to renew an icy surface, have not been documented anywhere in the solar system except on Pluto. However, it's essential to keep in mind that New Horizons conducted only a brief flyby, capturing observations of the region for just a single day. Confirming the current status of cryovolcanism on Pluto remains a challenge. Whether these exotic ice volcanoes are still active or have transitioned into a dormant state is yet to be determined. If indeed still active, it could enhance the likelihood of discovering a liquid ocean on Pluto, and perhaps even the potential for life. If you found this video engaging, please express your appreciation by liking it and subscribing to the channel. Join us on this cosmic exploration journey.